So this is an article about UHF RFID transponder with user interface. This is a new approach, I think, and the authors are, the names can be seen. Some words about the antecedents. Firstly, we had some competency in the field of RFID from earlier projects. We knew the advantages of the technology, but at the same time, we knew that there are some disadvantages concerning this technology. So, as a consequence, we thought that this contrast demands more R&D activities. And fortunately, there were a call, and we prepared an application, and finally, we won a grant 2 years ago. This project named Future RFID, and I have some words about this sentence, that IoT is Internet of Things, which means simply that more than 50,000 billion objects will be connected into a big network. And most of them doesn't have intelligence or communication capability, so it has some technology to connect them to the network. This is RFID or NFC technology. The Gen 5 means that the first generation of Internet was the Internet of computers. The second was the Internet of data. The third one, Internet of content. The fourth one, Internet of people. And the fifth one is Internet of Things. Our goal was to improve the RFID technology in order to wider spreading. In the first work package, we examined the known problems, and we determined that one of the most important is fears, the people's fears against the RFID technology, against the Big Brother effect, as maybe you know this term. We had discussed the areas using RFID technology, and we can separate into three parts of areas. These are business processes, relation of the government and the citizens, and the third is the everyday life applications. We will focus area which can be seen, yes, this one, when the application doesn't stay inside the business sphere, rather go out to the consumers. So, for example, you can buy anything in the shop, for example, a trousers with RFID tag. You can choose that kill this tag, and in the future you can use any advantages with them. But there are another choice. In the next slide we can see. So we concentrate this situation when UHF transponder will be inherited when people buying goods. The first approach was to detect the transponder and to save people that if they don't want to have transponder which answers any RFID readers, we had to find and kill them. But we have seen that this is not a very good solution because expensive, uncomfortable, and we can't use the transponder advantages in the future. So we had to change our mind, and we elaborated the next concept, and we said that we will change the transponder itself, and by in our opinion, it would be a good solution by adding an appropriate user interface to the UHF RFID transponder. We defined what behavior should be this interface. Firstly, should be capable not only to detect, but to control the behavior of the own transponder as well. Secondly, should be based on a widely used technology without any expensive infrastructure. This is very simple. And thirdly, should be the mandatory part of the future standard in order to dissolve the people's fears. Because that was our goal. We wrote the article, and it was published this year, spring, at the RFID journal site. And we are very proud of it because this was the first expert article from Hungary at RFID journal site. What was in the article? We proposed that the technology of the user interface should be the NFC technology, because NFC technology is spreading wider and wider nowadays, and the next years as well. In this article, we proved the feasibility, and we introduced some advantages of our choice. We examined the state machine of the present C1G2 standard. This is a class 1 generation 2 standard in EPC Global, and made some amendment for the future operation. So we had to integrate the new capability into the existing state machine. Let's see the feasibility. Earlier it was examined that there is no problem to combine antennas, which one of it UHF antenna and the other one is NFC. UHF operates in 855 to 58 megahertz, and NFC technology operates at 13.56 megahertz. So this is UHF, this is HF. And there is no problem to combine them. The feasibility of the chip, you can see the nowadays chip in the screen, at least the size of it. But if I press a button, you can see the chip itself. And we can see that it is almost a computer. So it's very, very complicated equipment. But you can see the size, it's very, very low size. And for example, at the C1 standard, the RFID chip had 10,000 transistors. And when was the transition to the class 1 generation 2 standard, it was 10 times more. And nowadays, we know some chips with newer 10 times more transistors. So it is no problem because in the worst case scenario, we can put together two protocols chip, and maximum the size has doubled. And it is no problem because an RFID transponder size is not determined by the chip. It is determined the antenna size. So there's no problem. About the price. In my opinion, the price is not a significant question because we know that any kind of production price mainly determined by the amount of ordering and producing. Next step was, if we had a new kind of transponder, to imagine what was if we put it into an NFC phone, And we can see that in this case, the covered area is very large. And we can use NFC phone from now, not only in some centimeters range, rather some meter, 4, 5, 6 meters range. And the next step, we could define a new kind of operation mode, which was unknown earlier. This is broadcasting. Broadcasting unknown earlier, I mean that in UHF RFID technology. We know this term from internet or from television broadcasting, but UHF RFID technology till now, a reader wanted only to get information from transponders and not to give information to them. It is logical because on the other side, we couldn't have any equipment which could make anything with this information. But from now, we have one. So, in our opinion, from now, this is as a result of the above, we could offer location-based services for few meters range, which was missing till now. We knew location-based services, for example, for a country, if you use your internet browser and your IP address, based on your IP address, the language will choose in Hungarian, for example. Or you can use location-based services, for example, a cellular network with your mobile phone. The next fuel station, you will get some discount if you go there. Or you could use Wi-Fi or Bluetooth network. But for a few meters range, we couldn't have till now. You can imagine that you can walk for a shopping street and you can go in front of a shopping door. You can get information about the actual discount, and the next door you can get another kind of information, and your mobile phone can say you that do you want or not. So the control is in your hands. Or another example, for disabled people, it is very good. You can imagine that the pavements are under construction, and blinded people can't know this information, but with this technology, he get information and maybe he get an alert on a mobile phone. So the future work, we are preparing a collaboration with some European universities, mainly for further research. And for the business sphere, we are preparing a collaboration with a Hungarian investment company, which could see some advantages in this technology and some idea about the possible applications. Thank you very much.